Video is about the discriminant and what we can use it for. So the discriminant is a number that describes a quadratic equation or function. There's a very short little formula for it. The discriminant, which I'm going to call d, is equal to b squared minus 4ac. Remembering, of course, that the b, a, and c that we're talking about here comes from ax squared plus bx plus c equals 0, or is f of x. We'll do a couple of examples here, and then we'll see what it all means. And once you get the hang of it, it's pretty fast to do this. Recognize the a, the b, and the c. A is 1, b is negative 12, c is 6. We do use all three of them, so we need to acknowledge all of them. The discriminant is b squared minus 4 times a times c. So that's 144 minus 24, or 120. And so that's your first one. It's pretty straightforward. It's not a lot that can complicate that. Sometimes the numbers get a little bit bigger. So we've got a equals 9, b equals negative 12 again, and c equals 4. So again, the discriminant is b squared minus 4 times a times c. And so that's 144 minus 4 times 9 is 36. 36 times 4 is 30 times 4 and 6 times 4. So that's 120 and 24. Well, that's 144. So this time the discriminant is 0. And then the last one, notice you got to be careful here. The a, b, and c, it's got to be equal 0. The a, b, and c need to be by themselves. So we do need to adjust this one just a little bit. Move that 33 over before identifying the a is 2, the b is 16, and the c is 33. But once we've moved that over, made sure that the sign of everything is right, we can do b squared minus 4 times a times c. And so these numbers are a little bit bigger. 16 squared is 256. And 8 times 33 is 8 times 30 and 8 times 3. So that's 240 and 24, which is 264. And so this discriminant is negative 8. So I want you to notice the difference between these three numbers, these three discriminants. We have a positive, a 0, and a negative. We're going to take a look at the graphs of each of these parabolas. I already have them from the graphing calculator, so we don't really need to go to Desmos right now. We'll just look at the three graphs. And what we're going to pay attention to are the x-intercepts. And this is the point of the discriminant, is to connect the equation of a quadratic to the number of x-intercepts, or the number of zeros for that quadratic. So when the quadratic was positive 120, there were 2 x-intercepts. When the discriminant was 0, there's only 1. And when the discriminant was negative, there actually aren't any x-intercepts. And that's always going to be true. So this is worth writing down in your notes. Whenever there is a positive discriminant, there will be 2 real roots. We'll get back to that in just a second. When there's a negative discriminant, there are no x-intercepts, but there are 2 imaginary roots. And when the discriminant is 0, there is 1 real root, which, by the way, has a name. When the root is also the vertex, there's a name for that. It's called the double root. It's kind of like it's a root from both sides from that side and from that side. It doesn't actually cross through. There's one more detail I want to add to this that's worth mentioning with the positive discriminant. As long as the discriminant is positive, there are two real roots. But I will say there are two different kinds of positive numbers here that lead to slight differences. If that positive discriminant is a perfect square, then there are two, not just real, but rational roots. And we'll see why in the next video. And if the positive discriminant is any other number, so not a perfect square, there are still two real roots, but they are irrational, which just means there's a radical involved. And in the next video, we'll kind of see why that's the case, why there's a connection between the discriminant and whether the roots are real or rational.